All right, welcome. We're going to talk about the first FRQ from the 10.9 homework. It is the sixth free response question from the 2019 BC Calculus exam. And it reads like this. A function f has derivatives of all orders for all real numbers x. A portion of the graph of f is shown above, along with the tangent line to the graph of f at x equals 0. Select derivatives of f at x equals 0 are given in the table above. So we have the second derivative, the third derivative, the fourth derivative of f at x equals 0. All right. Write the third degree Taylor polynomial for f at x equals 0. All right. So as soon as I see this third degree Taylor polynomial, that means I am going to need things like f of 0. I'm going to need f prime of 0 also, but I don't have those things because, as we have talked about frequently, the main thing we should always keep in mind, right, writing Taylor polynomials, we need to remember a Taylor polynomial formula. F, the kth derivative of f at a over k factorial times x minus a to the k. In this case, a is 0. And our f of x function, we don't have explicitly, but we do have a graph of it, right? So to write out our Taylor polynomial, this is going to be for part A. We are going to need f of 0, right? We're going to need f of 0. So let's go back up to our graph because it says we have the graph of f. Let's go up to our graph and see what we can figure out about our graph of f. Okay, here's our graph of f. We need f of 0. F of 0. F of 0, f here is 3. Okay, so I know f of 0 is 3. I also know for my next term I will need f prime of x at 0. So I would need f prime of 0. I'm not given that in my table, but I'm also told that in this graph I have the tangent line to the graph of f at x equals 0. And we know the first derivative. What is the first derivative? The first derivative is really just the slope of the tangent line, right? The first derivative is the slope of the tangent line. So what's the slope of this tangent line? It looks like it's down 2 over 1, so negative 2. All right. So I actually have f of 0. I found that from the point on this graph. F of 0 is 3. The tangent line here has a slope of negative 2, so there's the first derivative. I also know my other derivatives. F double prime of 0 is 3. F triple prime of 0 is negative 23 halves. And for this first part, I'm asked to write the third degree Taylor polynomial for f at x equals 0. So this is all the information I need. So I'm going to go ahead, I'm going to come back down, and let me finish actually writing out my third degree Taylor polynomial. So what is my third degree Taylor polynomial going to be? We can call it p sub 3 or whatever you want to call it. I'm going to call it p sub 3 here. Of x is going to be the 0th derivative at a, so that's 3, divided by 0 factorial times x minus a. A is 0, so it's just x to the 0, plus negative 2, my first derivative, divided by my 1 factorial times x minus a, but a is 0, so it's just x to the 1, plus 3 over 2 factorial, x squared, plus negative 23 over 2 over, this is my third term, so 3 factorial x cubed. I can go ahead and clean this stuff up. This is my my Taylor polynomial. So, because remember, you don't have to simplify stuff. So this, the thing that we're looking at here right now, will work. There's nothing wrong with it. You could leave it like this. In fact, it might be best to, unless you need to do some work with it later, which we do in this problem. So I will simplify this one up a little bit. So p sub 3, that got a little while. P sub 3 of x is going to be 3. 3 divided by 1, x to the 0 is 1, so that's 3. And it's going to be minus 2 divided by 1 times x, so minus 2x. Plus 3 divided by 2 factorial is 2, so that's 3 halves x squared. minus 23 over 2 divided by 3 factorial. 3 factorial is 6, so I'm going to multiply that into the denominator up here, so that's minus 23 over 2 times 6, which is 12x cubed. So there is my third degree Taylor polynomial for this function. And in terms of points here, you'll see on the scoring rubric, you got 1 point for writing out your first two terms, so 3 minus 2x or this, and then 1 point for your other remaining terms. So basically it's 1 point for the first two terms, 1 point for the remaining terms. There you go. Cool. Technically the rubric says 1 point for 2 of the terms, so as long as you got 2 of these correct, you're fine. 1 point for the remaining 2. So they come in pairs. It doesn't have to just be the first 2. But you should be able to get the first 2 and then the second 2. All right, let's look at part B. All right, I want to get a bigger eraser so I can keep my formula for things. All right, so part B. What does part B say? Part B is another reason why it's important to just remember your certain Maclaurin series. Because what does part B say? Part B says, write the first 3 non-zero terms of the Maclaurin series for each of the x. Okay, we can do that. That's easy. B, we want the first 3 terms of the Maclaurin series for each of the x. All you have to do is memorize these. That's why we have that quiz coming up. E to the x is going to be equal to, I guess it'd be approximately equal to e to the x, the first 3 terms will be 1 plus x squared over 2 factorial. The e to the x Maclaurin series is one of the easiest ones because it follows such like a clean, clear-cut pattern. The next one would be x cubed over 3 factorial plus x to the 4th over 4 factorial, and so on and so forth. So there we go. That's just the first part of B right there. That is 1 point for just getting the first 3 terms. All right. Then write the second degree Taylor polynomial for e to the x times f of x at x equals 0. Now here's the key thing. We want the second degree Taylor polynomial. So what I want to write here, just like a note to myself, second degree, whatever this is, I want to end at x squared. That's the biggest thing I want. I can't write any x cubed, anything bigger than that. Whatever this is going to end up being, I need to stop here. Okay? We'll see why that's important here in a moment. I want to write the second degree Taylor polynomial for e to the x times f of x. All right. So here's what we got. We want e to the x times f of x, right? And what do I know about e to the x? I know that e to the x is 1 plus x squared over 2 factorial. I'm just going to stop here because I don't want anything bigger than squared stuff, right? Times f of x. Now, what do I know about f of x? I already actually wrote out f of x. F of x, the first couple terms were 3 minus 2x, right? Plus 3 halves x squared. 3 halves x squared. And I'm actually going to stop there, right? Because the biggest thing I want for this new series I'm going to write is these squared terms. If I go to the cube terms that I wrote out above, then like the minus 23 over 12x cubed, when it multiplies over here, distributes, I'm going to get something bigger than the squared. So I'm actually just going to stop here. That is all that I really want, right? This is all that I really want right now. All right. Now, you could, if you want to, now take the time to distribute and then combine like terms, but we can be a little smart about this. We know this 1 is going to distribute to all of these. Well, 1 times all of these, I'm going to keep all of those things because I just need nothing bigger than x squared. So when I distribute, I'm going to go ahead and write this out in the next line. E to the x times f of x. I guess this should also be approximately here. Will be approximately 1 times all of these terms will still be at or less than a power of 2. So I'm just going to kind of copy those things over. 3 minus 2x plus 3 halves x squared, because 1 times all of those are keepable. Okay. Then I can say plus x times, so that's x times 3 I would keep, minus x times 2x. I would keep that one because that would give me x squared when I distribute that into both those. But I'm not going to write anything down for this one because x times 3 halves x squared will give me a bigger power than I want. Okay, and then I can say plus x squared over 2 factorial. When I distribute that in, all it can multiply in and be safe is the 3. So it's times 3. Because if I distribute FOIL this one over here, I'd get to the third power of x and so on. So I don't want to multiply those things in. So there we go. If you want to, you can think about this. This is a 1 times that in front. So it's 1 times all that stuff to get to power 2. X times just the first 2 to get to a power of 2. X squared over 2 factorial times just the 3 to get to the power of 2. There we go. So this is what we're looking for. We just need to spend some time cleaning this up. If you don't like that process, you could actually FOIL and distribute everything, 1 times that, 1 times that, 1 times that, 1 times that, x times that, and then combine like terms and cut it down to just the x squared things. All right, so we can clean this stuff up a little bit. This is going to be 3 minus 2x plus 3 over 2x squared plus 3x minus 2x squared plus 3x squared over 2 factorial, right? All right, let's combine some like terms, see what's going on here. We have 3. It doesn't have any like terms, so it's going to be 3 minus 2x plus 3x. Combined like terms will give us a plus x. 3 halves x squared. So has 3 partners. So let's just write this down for now. 3 halves x squared minus 2x. 3x squared over 2 factorial is also just 3x squared over 2. All right, so my last step here, what does this all combine to? 3 plus x. 3 halves x squared plus 3 halves x squared will give me, combining these two, 6x squared over 2. So that's 3x squared minus 2x will give me, oh, I lost my squared on there. Minus 2x squared will give me just an x squared left over when I combine these terms right here. All right. So 3 plus x squared. That would be my the first 3 terms, which is the second degree Taylor polynomial for e to the x times f of x. And we could say then that p 2 of x is 3 plus x squared. All right, point-wise, this one, you got 1 point for just knowing your terms to e to the x, and then you got 1 point for your 3 terms over here, okay? All right, let's take a look at part C. All right, part C. Let h be the function defined by the integral there, okay? If h of x, then h of x is the integral from 0 to x of f of t dt. I'm just going to write out what I know this means then. This is the integral from 0 to x of, I knew what I wrote down for f of x. It was 3, if I'm going to replace things with t. 3 minus 2t plus 3 halves t squared minus 23 twelfths t cubed dt. Notice I not even read the problem. I'm just like rewriting what they're already telling me here, right? All right, use the Taylor polynomial found in part A. That's what I did here to find an approximation of h of 1. Okay, that doesn't sound too bad. H of 1 then is the integral from 0 to 1 of 3 minus 2t plus 3 over 2t squared minus 23 over 12t cubed dt. I can take my antiderivative. The antiderivative would be 3t minus t squared plus half t cubed minus, this one gets a little, because I need to add 1 to the exponent and then divide by that exponent. So this is going to be 23 over 48t cubed evaluated from 0 to 1. Okay? That is my antiderivative. Take a look at that for a second. Double check your work. Nope, I wrote to the third power there for some reason. That's why you double check your work. Okay, not to the third power. Said one thing, wrote another to the fourth power. There we go. Double check your work. Great. And then we got to plug in. Remember, you don't have to simplify, but you at least have to plug stuff in. Plugging in 1 is nice and easy because you would get 3 minus 1 plus half minus 23 48ths. And then plugging in 0 is easy because you just get 0. So this is our answer here. Unsimplified. And remember, you don't have to simplify anything down if you really wanted to and you're feeling gung-ho about it, but I would not encourage this. You would get 97 48ths. All right. Point-wise here, you get 1 point for your antiderivative correctly. Good thing I went back and checked that. 1 point for your antiderivative. And then 1 point for your final answer. All right. Hopefully this helps you get started with this FRQ. Be sure you fill out the score report. Bye.